Alright, so I'm working through that first problem again and breaking it down to 2 steps. The goal is to get this into a 1-step problem like I did in the video, and we'll build up to that. But we'll do this as a 2-step problem so you can sort of maybe see this broken down a little bit further. We know we're starting off with 9.5 grams of sodium, and by the way, if you're lost right now, remember that this is the video for extra help with number 1. So we're starting off with 9.5 grams of sodium, and the question's asking how many moles of oxygen do we need? So we know we have 9.5 grams of sodium, we need how many moles of oxygen? We've already set this up over here with our graphic organizer. We are starting in the mass of sodium, because that's what they gave us, and we're going to the number of moles of oxygen. So we've got 2 steps, and we can actually work these out as 2 separate problems. So let's do problem number 1. Problem number 1 down there is just a mass to moles problem like you've been doing for the past couple of weeks now. So we start off with 9.5 grams of sodium, and we'll just do a 1-step problem where we're trying to figure out how many moles of sodium that is. To do that, we know we need grams of sodium on the bottom, moles of sodium on top. Remember that will allow grams and grams to cancel out. Now, just like any of the molar mass problems, to figure out the molar mass, we need to look at the periodic table. And we look it up on the periodic table. And 1 mole of sodium is equal to 22.99 grams of sodium. Remember, when you're getting the number from the periodic table, whichever one it is, whether it's one online or a physical one in the back of a textbook or one you took home with you, you want 2 digits past the decimal. You want all the way out to the hundredths place. You can go digits further than that, but when we're working these problems, the numbers I'm going to be using, I'm always going to go to 2 digits past the decimal. So I'm always going to go to that hundredths place, the second decimal place. So if you want your answers to make sure they absolutely match mine, do that. So 1 mole of sodium is equal to 22.99 grams of sodium. Now, we see that grams of sodium cancel out with grams of sodium, and what you've got left is 9.5 times 1 is itself, so that's 9.5 moles of sodium. Let me rewrite that. Over 22.99, and then grams cancel it out. So this is same kind of 1-step problems that you did 16 of in that mixed practice assignment. So go ahead and take a second, plug that into your calculator. 9.5 divided by 22.99, and you should get an answer that looks like 0.4132 moles of sodium. So that's the first answer to problem number 1. And that answer to problem number 1 is going to be the answer it's going to be the starting number we use for problem number 2. So that second arrow where we do problem number 2, that's the answer we're going to start with. So for problem number 2 then, I'll rewrite this, 0.4132. We'll multiply that by a conversion factor. And remember that this number is just the answer to this problem up here. Our answer for problem number 1 is our beginning number for problem number 2. So this time, we are here. You see arrow 2, it takes us from moles of sodium to moles of oxygen. So we'll put moles of sodium on the bottom, where we're starting, so we want that to cancel out. And we'll put the other side on top, moles of oxygen. Now, this is a mole ratio. Look at the video on mole ratios from a week ago. It's been a while. To fill in a mole ratio, we are going to use our recipe, our balanced chemical equation. And we're going to use the coefficients, the big numbers that are in front of our chemical formulas, to fill in the number parts here. We know the units, but we don't know the numbers. So I like to start on the bottom, because that's what, I don't know, I start on the bottom. You can always start on the top if you want, but moles of sodium. Let's find sodium up here, Na. Well, Na is all the way over here. And we see that for this recipe, we need 4 sodium atoms, or 4 moles of sodium. So 4 will go down there with moles of sodium. Now to find oxygen, O2, we'll do the same thing. We'll find O2 in this chemical equation, and we see O2 is right here. But there is no coefficient there. Remember that in chemistry, if there's no coefficient, that actually just means there's a 1. We assume that there's at least 1. So that means we're going to put a 1 right here. Now, we take 0.4132. Oh, well, let's see what's canceled out first, actually. Let's see. Moles of sodium cancel out with moles of sodium. Sorry about that. So 0.4132. That canceled out. Times 1 is still itself. Moles of oxygen. I'm going to draw my arrow because I've run out of room. I'm sorry. Over 4. And that canceled out. So the last thing we need to do now is just solve this little division problem. 0.4132 divided by 4. So go ahead and put that in your calculator. 0.4132 divided by 4 should give you 0.1033 moles of oxygen. I'll write this below it. All right. Give me 1 second. Now, the last thing we need to do is check significant figures, okay? So for significant figures, we look up here at that first number we were given in the problem. This is the number we were given in the problem. I wrote it up there, and we wrote it again right there. We see that there are 2 significant figures there. We need 2 significant figures in our answer. Remember that this leading 0 is never ever significant. So that means we'll have the 0 point, and then here's our first sig fig. 1, 0 will be our second sig fig. Remember, this 0 is significant. Sorry, this 0 is not significant because it's a leading 0. This 0 is significant because it's a trailing 0 after the decimal. So, we can do this all as one big problem. And for problem number 2, go back into the video and you will see, actually if you go back into the video and watch problem number 1 again, you'll see that all we did was we took this conversion factor, we set this problem up the same, and then we just took this conversion factor and just tagged it on the end. So all we did was take the conversion factor here, tag it on the end, so that we set up the problem like we did for our first problem, and then just added this conversion factor from the second problem. You should already be able to do both of those steps, which doing is one big problem. And when you do it as one big problem, it looks overwhelming and some people don't know where to start. Start by looking at everything in the numerator. That's your number on the left, and then everything on the top, and multiply all those together, and write it off to the right. Then, look at everything in the denominator, multiply all those together, write it off on the right in the denominator. Then you can take your numerator and divide by your denominator. So this is taking that first problem and breaking it out into 2 steps. We want you to get to the point where you can do it all as one step, like this right here. So hopefully this video helped break it down a little bit further. You can go back and watch the other video and finish that up. We'll try some of the practice problems, 3 or 4 and 5, and there will be a video playlist of those posted as well. So again, hope you're all staying safe and healthy, and I will, you might see me again in another video.